Yeah, good morning, all.
Morning, sir.
Good morning. Let's start the class.
Yes, sir.
Yes, definitely. Right. Yeah, today I'm going to start the topic last block, that is natural product. Yeah, my voice is audible to you all?
Yes, sir.
Yes, sir.
Yes, okay. My screen is my screen
Yes, sir.
right. The movement also, the cursor
Movement.
movement also.
Yeah, cursor movement is okay, sir.
Yeah, right. Right. I'm going to start in 16th lesson, unit 16, natural products and terpenes and terpenoids. Yeah, so going to the interest of the terpenes and terpenoids. First, you need to know what are the natural products. My first question is, what are natural? Yeah. Yes. Suppose in our ancient days, we are using Ayurveda, homeopathy, so many medicines, right? Then some active constituent is present, or any active compound is present in that is isolated from the plant or any other natural sources, that is used as a drug. Here, whenever we are considering the medicinal field, the drug is important entity. But whenever we are coming to chemistry, any chemical substance which is isolated from nature. Nature means either it may be a plant, either it may be an animal, either it may be a soil, or it may be a marine plants and marine soil and marine water. These are the natural resources. Therefore, any compound or any material or any chemical entity which is isolated from nature is called natural product. Natural product. That may be anything, but when it will be studied, it has a special property. It has a special property. Now, suppose in the antibacterial drug, now we are using some chloroquinolin drugs are using, but the chloroquinolin drugs are the synthesized drugs. In the initial, we are using a quinine. Quinine is the naturally isolated medicine for the malaria. Right? It is isolated from a plant that is called Cinchona somniferum. Right? Therefore, here the quinine is the natural product. It has some special properties. It has the properties to cure the malaria. Therefore, whenever we are keeping the concentration on the compound which is isolated from the nature, that is purely called as natural product. Right? So many compounds are isolated from the nature, which is utilized as a drugs and in the for so many applications in the field of day to life in the daily life. Right? Now, first you take the definition. Any chemical compound isolated from nature, that is plants, animals, microorganisms like bacteria, virus, fungus, like that. Microorganisms. Next, soil. Example for soil tetracyclines. Soils, uh, marines, marine plants, right? It is are known as natural product. In chemistry, natural products are having very important and essential things are also, because most of the drugs and most of the medicine are developed based on the natural products. Previously, we identified some natural products that is utilized as some physiological activity. It is having, suppose if it is having poor physiological activity, by modifying that naturally occurring substance into new compounds, then we can improve the physiological activity. Based on that, we can introduce the new drugs in the market, right? Due to that reason, natural products are having so much importance. Then the chemical compounds which are obtained from nature and are isolated from nature, like plants, animals, microorganisms, or marine species, or a soil, etc., are termed as natural products. Commonly, these natural products are classified into different classes. Some of them are terpenoids, and alkalides. Carbohydrates also natural products. Carbohydrates. Next. Steroids. Hormones. These are isolated from the most of them living beings, animals, like that. Hormones. Uh, terpenoids. Terpenes are terpenoids, alkaloids, carbohydrates, steroids, hormones, prostaglandins, porphyrins. These are all natural products. Then, how these natural products are classified? Natural products are classified. Steroids, cholesterol. Steroids are already given. Example of steroids, cholesterol, testosterone. Testosterone is the example of the hormone. Cholesterol, um, estrogen. Estrogen is also cholesterol hormone. Okay. There are some basic part of the hormones are from the steroid. Okay. Whenever we are going to discuss those topics in deeply, we can discuss. Right. Coming to the natural products, first isolated from the nature, that is maybe plant, animal, or microorganisms. Now these are again classified into two types. One is, that means in the products are obtained in the two forms. Based on that, the natural products are also two types. One is primary metabolites, and secondary metabolites. Primary metabolites and secondary metabolites. These primary metabolites means these are the compounds which are essential for the cell survival and function. These are essential for cell survival. And more vast definition is also there. People may or more known about that. I don't want to go into that. Okay. Next, secondary metabolites. These are not essential, but some in most of the cases byproducts of the metabolism. Okay. not so essential, but useful for the survival of cell. Useful for the survival of cell. For example, for primary metabolites and secondary metabolites, we can take nucleic acids. First coming with the amino acids. These are the building blocks for the proteins. Amino acids to the form of peptides, protein, nucleic acids, enzymes, sugars like glucose, fructose, sugar. Now, these are all essential. Without the amino acid, we cannot produce the cell, or without protein peptide, we cannot produce the cell. And without nucleic acid, there is no RNA, DNA. And without enzyme, there is no production of proteins. That is the combination of amino acids and some coenzyme parts that releases the complete proteins. Right? Now, these are very much essential for the cell survival and cell function, both. Now, when you're coming to the secondary metabolites, for example, perfumes, toxins, venoms, right? Colors, pigments and colors. These are all called as secondary metabolites. These are primary metabolites. Okay, all these are natural products. Now, next, what are the advantage of, or what are the applications of natural products? First thing, natural products are medicines or drugs. Natural products as medicine or drugs. Right. Most of the natural products are useful or used
Excuse me, sir.
Yes.
Screen down chair, sir. First.
Yeah. Okay.
Okay, sir.
Right. Can I scroll up?
Okay, sir.
Right. Then, natural products as drugs. Most of the natural products are used because natural products, if you are known, that is having some importance as a drug. Due to that reason, we are already known it. Due to that reason, in the natural products literature, most of the compounds isolated from the nature are having some specific activity. The specific activity is most of them are drugs and medicine. Okay. Then, for example, drugs as natural drugs as drugs. For example, morphine. Nowadays, it is some restricted drug. It is only given to the pain management for carcinoma. This is morphine. And narcotic and hypnotic drug is Next, quinine is an anti-malarial agent. Yeah, my entire life on quinoline molecule for research. Almost that molecule. Quinine. This is isolated from cinchona bar. Isolated from cinchona bar, and what is its activity? Anti-malarial. The first generation anti-malarial agent. Later, we have modified several drugs from this molecule. Next, everybody knows penicillin. Yes, this is penicillin. Penicillin called it as you know that a powerful antibacterial agent. It is the origin for the antibacterial era. Broad spectrum antibacterial. Next, other you know that. What is the history of penicillin? How it is isolated? Alexander Fleming, how it is isolated. Okay. Next, ephedrine, a cough syrup medicine. It is. And the SIT product, most of the stroke at least one thing. So SIT, it is showing the medicinal activity. Ephedrine, it is anti-asthmatic. Or bronchial relaxation. Right. So these are some of the compounds and so many valves that so structure is very vast in nature. If you take wind blasting, is the bulkier compound and levastatin. Are also isolated from the nature. Right? These are used as with the first one. If you take the levastatin, wind blasting and Taxol is for treating the cancer. Right. Next, levastatin is for the treating the cholesterol. For cholesterol treatment, we can use it. Then, these are some of the natural products used as drugs. Now, coming to our topic, this is some basics for the natural products. Next, coming to terpenes and terpenoids. This is our lesson, 16th unit. Terpenes and terpenoids. Right. In olden days, these are also called essential oils. These are also called as essential oils. Both of them are commonly named as essential oils. How these are defined? In earlier days, the terpenoids is used to a mixture of isomeric hydrocarbons with molecular formula C10 H60 occurring in turpentine and other many essential oils. In the previous days, we called it as essential oils, or in which is essential oil. One of them is turpentine oil. Everybody knows turpentine. Turpentine nowadays is also it is Ayurvedic shops and medical shops, and general kirana shops also selling this turpentine oil, right? Uh, in the turpentine, whenever the research workers are studying on that turpentine oil, they are isolating some compounds which are having only carbon and hydrogen along with some oxygen sometimes are known as terpenoids. They named it as turpentine oil, terpenes, which are having the molecular formula C10 and H16. Now, these are known as terpenoids. Right. The molecules which are having the molecular formula C10 and H16 occurring from the turpentine and many other essential oils are known as terpenoids. At the same time, the oxygen derivatives like alcohols, aldehydes, the ketones of are are also isolated from these essential oils. One side, they are isolated. This hydrocarbon and hydrogen containing molecules are isolated. They are named as terpenoids. At the same time, using the same essential oil or turpentine, they are isolating the molecules with carbon and hydrogen formulas and oxygen. This oxygen may exist in the form of alcohol, aldehyde, or ketone. Aldehyde or ketone. These are known as camphor derivatives. Camphor. Nowadays it is called. What is that camphor? Karpuram. These are known as camphors. But the time is progressing, but the discovery of these compounds are increasing with time. To cover all these compounds, there is a need to modify the definition of these terms. That is, terpenes and terpenoids and camphors, we need to modify. Again, I'm repeating, but the discovery of these compounds are increasing with time. To cover all these compounds, modify the definition of these terms and molecular form. From this, they are proposing one definition, that is the compound which are the compound having molecular formula C5H3N are known as terpenes, at the same time its oxygen derivatives. That is, at the same time its oxygen derivatives that is found with molecular formula C5, H5, sorry, H8, C5, H8, along with oxygen may be N, are known as terpenoids. This is different from the first definition. The first definition, just C10H16 are having terpenoids, and C10H16ON are known as compounds. But later, the number of compounds are increasing, and there is necessary to address these compounds in the taxonomical basis. For that reason, these are modified into two terms. One is the terpenoid, terpenes, and the terpenoids. Those compounds which are having C5 and H8 molecular formula, basically, those are known as terpenes. And those oxygen derivatives, C5H8 and ON, are known as terpenoids. From this statement, we can conclude that all the terpenes are terpenoids, but vice versa is not. Because we can also, from the old definition and comparing with the new definition, all the compounds C5H8 are terpenoids, but all terpenoids will not become the terpenes. Okay, that statement you need to remember. Okay, this is the basic definition of terpenes and the terpenoids. Classification of terpenes. Terpenoids. Classification of terpenes. Classification of terpenes. The compound, suppose if you take any terpene or terpenoid, subjected to degradation, then it leads to produce a unique H2 double bond NH. Now this is known as, its IUPAC name is 2-methyl. 1, 2, 3, 4. A butene 1,3-butadiene derivative. 2-methyl, 1,3 butadiene. 1,3 butadiene. This common name is also called isoprene. Now this is the isoprene unit. This is one basic unit present in the terpenes and the terpenoids, which are resulted whenever we are subjected to the degradation of terpenes and the terpenoids. Now, the isoprene rule is there. What is the isoprene rule? In terpene or terpenoid is subjected to degradation. It leaves produce isoprene, the major. This rule is known as isoprene rule. Isoprene rule. What is the isoprene rule? Any naturally occurring, generally terpenes and terpenoids all are naturally occurring. There is no still some of them are known synthesized one, but most of the terpenes and terpenoids are naturally occurring. Any terpene and terpenoid is subjected to degradation. It leads to produce isoprene is the major product. Then that is known as isoprene rule. This rule is also called, other name is there for this rule, that is Walsh rule. All the naturally occurring terpenes are built up with the all the naturally occurring terpenoids and terpenes are built up of isoprene units. It can be represented as isoprene. Now, its chemical name is 2-methyl 1,3-butadiene. Then all the naturally occurring terpenoids and terpenes undergo thermal or chemical degradation. Degradation may be thermal or chemical if you are applying any reagent. Chemical degradation, that is thermal or chemical degradation, that leads to the formation of isoprene is the major product. That is known as isoprene rule. Now, whenever we are going to classify these terpenoids, terpenes, we need to consider as terpene is the basic, isoprene is the basic unit. Isoprene is the basic unit. Now, what is the chemical formula of isoprene? Here from this formula, how many carbons? 5 carbons. How many hydrogens? 2 plus 3, 2 plus 4, 6 plus 2, 8. 8 hydrogens. Now, based on the number of these isoprene units present in the molecule, terpene molecule or terpenoid molecule, we are going to classify the terpenoids or terpenes. Now, to take the where n is equal to number of terpene units, number of isoprene units. Number of terpene units. And number of carbons. This is also equal to how many number of carbons we need to include. Then molecular formula. Based on the carbon, we can include the number of hydrogen by which we can get the molecular formula. Then what is the compound name? Name of the terpene or terpenoid. Where n is equal to 1, for example. When 1 is equal to 1, C5H8 taken N. This is the general formula for terpene or terpenoid. Okay. Now, where n is equal to 1. Now, what is the formula? H8 and the molecular formula is C5H8. Now, this terpene is know that isoprene name, or it is also named next, second one. Say n is equal to 2. That is n is 2 into 5, 10, 10, 2 into 8, 16. Right. The number of only you here is to make the number of carbons from the molecular formula. C10, H10. Like that. Simply make the number. Then what is the name? Monoterpene. Or simple terpene. It is terpene. Next, third one. Number of carbons are 15 plus 1. C15, H20. Sesquiu terpene. I think it is already covered in UG level. You know, you can follow it. Okay. Next, 4 number of where n is equal to 4, is the number of carbons are 20, C20, H32, diterpene, number of where n is equal to 5, the number of carbons are 25, 5, H40, that is testosterone, right? Number of where n is equal to 6, number of carbons are 30, this is triterpene, it's not triterpene. Next, the last one. Then you can also name several up to 50, 60 also, but I am leaving here. There is almost the 35 is the biggest terpene, which we are going to last. 35 H64 tetraterpene. Terpene. These are also known as carotenoids. Tetraterpene, not tetraterpene. Tetraterpene. And coming to 8, 40, 40. Oh, what is it? This is tetraterpene. It is known as carotenoid, also known as carotenoid. For example, for carotenoid, vitamin A, carotene, alpha carotene, gamma, omega, beta carotene, etc. Okay. Abiotic acid is also for the terpenoid. Okay. Now, some of the examples. This is the common table, classification table of where n is equal to 8. So, for some examples, monoterpenes. This is lemano. And the next one. Alpha pinene. This is medicine. And these are the monoterpenes. Coming to terpenoids, monoterpenoids. Whenever we are adding some oxygen derivative, oxygen function to the above terpenes, that is converted into terpenoid. Terpenoid. For example, some aldehyde function for this case, we are adding one methyl group at this position and a aldehyde group at adding one oxygen particle. Now it is called as citrol. Called as citrol or aldehyde. No? There is a citrol. Next, alpha terpinol. One right to the just bond is an oxidation that leads to the formation of just the oxidation reacting with the some dilute acid that leads to formation of an alcohol that is called alpha terpinol. 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 Next, menthol. How many of you know menthol? You feel it, you feel it like a cool, what we call cool feeling is given camphor. Camphor is a true oxide. Camphor also right like this also. Or metal and metal here. This is terpenoids. Just two terpenes. We have several examples of this there in your book. You can also take out from your book. Just two terpenes. Digelberine and sembrine and vitamin A. There is a carotenoid example for that. And triterpenoids, oleanoic acid, and tetraterpene, beta carotene, the example for the different kinds of terpenes and terpenoids. Okay. Next, coming to general rules in terpenoid chemistry. Have already we discussed the isopropyl group. General rule in terpenoid chemistry. The first rule is isopropyl. Or also called as we already discussed previously. I'm skipping it now. Next, yeah. Second rule is isoprene rule, special isoprene rule. Isoprene rule. In the special isoprene rule, what is that? Whenever we are taking the terpene, right, when we start to the degradation, whether it is maybe chemical or thermal degradation, Yeah. Okay. Whenever we are considering this terpenoid, terpenes or terpenoids and degradation, this degradation is not complete degradation, partial degradation. Whenever we are is partial degradation. That partial degradation means, suppose if you want to break an article, you just broke it into two parts. That is partial degradation. We broke it into 100 parts. That is complete degradation. Right? Similarly, here also, whenever you are taking the terpene or terpenoid, when you are subject to thermal or chemical degradation, you need to stop the degradation in the middle. Right? At the middle stage, we are isolated some products. Those products are, we are observed like that. These are the degradation products. When it leads the partially degraded product. Partial degradation. Partial degradation product. In the partial degradation products, these isoprenes are linked in the partial degradation products are headed to tail manner. Headed to tail manner. What is head? What is tail? Now, when you come to isoprene, look at here, the isoprene. Now, at this end, methyl group substitution is there. This end is known as head. This end is known as head. And this end is known as. Now, whenever we are isolating these partial degradation products, suppose we are isolating one of the product like that. Like that. Okay. Now, each isoprene, how many number of carbons in the straight chain? How many number of carbons in straight chain? 1, 3, 4, 5, 6, 7, and 8. In each isoprene, how many? 1, 2, 3. The 4 straight chains. That way, now this is the attaching bond between the two isoprenes. This is the attaching bond. This is the linking bond. In this, therefore, this is one one isoprene. This is another isoprene. Two isoprenes are linked together. This sigma bond. Now, how these are linked? This is the first isoprene. This is the tail part, and this is the second isoprene. This is the head part. The two are linked in head to tail or tail to head manner. Head to tail or tail to head manner. Now, this special isoprene rule tell that the isoprene units in natural terpenoids are joined head to tail, or head being the branched end of the isoprene. That divisibility into isoprene units, their head to tail union is known as special isoprene rule. You forget about the systematic construction in your book. You forget about it. You just write that. What is the special isoprene rule? Naturally occurring terpenoids are undergoes partial degradation, degradated product are found to be iso two isoprene units are linked in to tail or tail to head manner. from this naturally occurring terpenoid, naturally occurring terpenoid isoprene occurring isoprene units are linked to is known as isoprene rule. Is known as special isoprene rule. What is isoprene rule? Any terpene or terpenoid subjected to degradation that leads to the formation of isoprene as the major product. That is the isoprene rule. Whenever we are coming to the same terpenes and terpenoids subjected to the partial degradation that leads to the degraded product, in the degraded products, we observed that the isoprene units are arranged like a head to tail or tail to head linkage manner. From that, we conclude that any naturally occurring terpenoid isoprene units are linked in head to tail or tail to head manner are known as special isoprene rule. Okay, that means these two rules are explaining the structural organization of terpene and terpenoids. In that structural organization, all the terpenes and terpenoids are constructed with the isoprene rule, that isoprene unit. That is isoprene rule. In the second, we come into in the all the naturally occurring terpenoids and terpenes, isoprene units are linked in such a way that head to tail linkage. That is special isoprene rule. Next, third rule is gem dialkyl rule. Gem dialkyl rule.
Excuse me, sir.
Yes.
Screen down చేయరా?
Okay. Gem dialkyl rule. This is also very much important. Why it is important, I will tell you. Right. Can I push up?
Yes, sir.
Right. Suppose you consider this is a cyclohexane. Cyclohexane. You know that the cyclohexane is in the form of chair form. Right. It is the more stable conformation. More stable conformation structure. When this same cyclohexane is attached with two methyl groups on the position are known as geminal substituted cyclohexane, also called geminal dialkyl cyclohexane. Geminal dimethyl cyclohexane. For example, the same two methyl groups are adjacent to each other. Substitute. Vicinal dimethyl cyclohexane. Now, when we compare to the vicinal and geminal, we get here. Suppose this is the first position and treated with as first position. This methyl group is, and another methyl group is like this. One is arranged to axial and one is acyclic. Sorry. Both are the germ. One is the axial, right? The same thing of this vicinal. The methyl position and second methyl group. This is stable. Now, when we compare, this is the first one, this is the second. The second is more stable than the second one. More stable than the second one, because in the simple cycloalkanes like cyclohexane, cyclopropane, cyclopentane, cyclobutane, or other higher number, cycloheptane, cyclooctane. When two methyl groups, not only two methyl groups, any similar substitution on the same carbon are known as geminal substitution. Any substitutions are adjacent position or vicinal substitutions. When you compare the stabilities, gem dimethyl or geminal substituted cycloalkanes are less stable when we compare to the vicinal substitute. And also here the comparison is why we are proposing gem dialkyl rule. At the same time, when we comparing, these molecules are unstable when we compare to the first one, vicinal, right? Look at it. Whenever this term is, there are simple cycloalkane chain form, cyclohexane chain form. Okay. Now it is unstable, very unstable, right? The same cyclohexane derivative, gem dialkyl cyclohexane derivative, is regularly observed in the naturally isolated terpenes and terpenoids, are having more stability. For example, you take simple camphor. This is the camphor. Yeah. This position is a carbon. This is one methyl. This is another methyl. And another methyl is here. And here double bond. Look at here. This carbon position is known as gem dimethyl position. Gem or gem dialkyl position. Now, this camphor is arranged in the non-planar structure. In this non-planar structure, non-planar bicycloform of structure. This is CH3, and another CH3. This CH3 is this one. These two CH3s are this one. Right? Now, this is the structure of camphor. The camphor is more stable due to the presence of these two methyl groups. Its geometry is fixed due to the presence of these two methyl groups, pivotal methyl groups. Therefore, there is a rule or there is a common observation. A gem dialkyl group containing naturally occurring terpenes are more stable than their corresponding simple geminal substituted cycloalkanes. This is known as gem dialkyl rule. I'm repeating. Occurring terpenes or terpenoids with gem dialkyl groups have the stability than the corresponding cycloalkanes with same dialkyl. as gem dialkyl rule. Gem dialkyl rule. Here I'm saying here they are termed as gem dialkyl. Alkyl group is any R group. R group is present on the same carbon. Okay. The simplest R group is methyl. That's why I'm taking simple methyl groups for explaining this group. Okay, not only methyl group, sometimes ethyl groups are there, sometimes propyl group also there. Okay, commonly alkyl groups are considered. That is the reason we call it as gem dialkyl group. Okay, I think you followed. Next, isolation of monoterpenoids. Isolation of monoterpenoids. Yes, how these terpenoids are only terpenoids, natural products are isolated. Isolation can be carried out by extraction method, steam distillation or distillation method, or solvent extraction can also do the normal way, or in the form of soxhlet extraction. Soxhlet. What is the extraction? Suppose you conducted some natural products. This is natural products. These natural products may be or microorganisms like anything, or it is maybe a soil sample, or it may be a animal like a human being, human waste or animal waste. Okay. Now you collected the raw material. This is the raw material. This raw material take with some solvent. That solvent may be a aqueous alkaline or acidic or organic. Okay. These are alkaline solution, acidic solution, or organic solvent. Just add these solvents and stir it for some time. Then filter it. Then subject to the filtration. Then you will get the dissolved undissolved residue. Then this filtrate will be residue. Filtrate will be filtrate. This filtrate again different kinds of solvents to separate the mixture of compound and just evaporate the solvent to get the compound. That is extraction. Next, distillation method. Again, this distillation method are several types. That is steam distillation, and vacuum distillation. Vacuum distillation. It is okay, several fractional distillations. Right. There are several types of distillation methods are there. In the distillation method, first you can do distillation. Just take the raw material. Yes, this is the raw one part. You take the raw material. This raw material is filled with the water, right? We are passing groundwater blast treated as. You are heat it with the heat source. At the same time, we are passing the steam. The steam will move through the solution, water solution, then it exits out. Whenever this steam is steam in, this is steam out. whenever this is coming out, it dissolves some essential products or some natural products which are having below 100 degrees what you call vaporization boiling points. Below 100 degrees vaporization points are boiling point. Those compounds come along with the steam. Then here the steam is collected, which is passing through one condenser, which is passing through this condenser. This condenser is cooled down with by passing the cold water. Then the water will be, the steam is water, you know. Okay, the steam again converted into water along with that natural product accompanying. You know that natural products are most of the organic compounds. Those organic compounds are insoluble at a lower temperature. Maybe it is soluble in the steam, but whenever it is cooled down, it is insoluble. Therefore, once they are liquid, the steam is liquefied. There is at the collection point. This is the collection point. Suppose this is collection point. Now the water is bottom. Then the collected organic compound or natural products will generate. Therefore, these two layers are separated into two different layers, individual layers. One layer containing the natural products, one layer containing the water. Right? This is the steam distillation. Normal distillation is also more similar to that, but we are not using the steam here. Just boil it. Just boil it at that boiling temperature. Based on the boiling temperature, suppose if you take some compound is having 70 degrees centigrade, some compound is having 60 degrees temperature. Some compound is having 5 degrees. Now, using these things, we can boil the solution. At 55 degrees, one compound is separated. At 60 degrees, one compound is separated. 70 degrees, one compound is separated. Right? Based on that, we can separate the compounds. The same principle is applicable for the vacuum distillation and fractional distillation also. In the vacuum distillation, we are applying some vacuum. Why we are applying some vacuum? Suppose this compound contains 3 compounds are there in the mixture. In one compound is degraded at higher temperature. To avoid the reaching the higher temperature, we applying some pressure to leave the vapors which are generated in the pot as a pure product. Then we are applying the vacuum. Based on the applying the vacuum strength or vacuum power, we can isolate the compounds in the distillation. Now this is the steam distillation, normal distillation, vacuum distillation, fractional distillation. Now the third one is oxalate extract. So oxalate extract is, this is a simple another method. We are using a oxalate operator. This is a oxalate operator. Suppose we consider it is this is the round bottom glass. Now we are inserted oxalate pocket. Oxalate pocket is like this. Oxalate pocket is like this. In the oxalate pocket, in the oxalate pocket, we are insert raw material. Now, there is a link point. There is a connection like this pipe. It will be connected to one of the condenser. That condenser is like this. The solvent is boiled up. The solvent is boiled up. Here it is cooled by passing the water. Right. This cooled solvent is almost to cooling. Just it is liquefied. Once it is liquefied, these drops are. This hot solvent will be dropped into this pocket. Then this hot solvent dissolves the natural product. Then, whenever it is filled, that fill will be again is reconnected to the pot. Now, once it is filled, the solvent the solvent is returned to the pot. How is evaporated when we are applying the heat source? Now, in this is the regular method. Here, this method is advantageous to avoid contacting of unwanted residue in the solvent, or if some undissolved substance may be contact with the solvent, that may be dissolved. Okay, At the hot temperature, it is in this method we are avoiding the filtration. Just at the during the extraction, during the heating, the solvent will collect the natural from the raw material. Then the solvent will reach to the original source point. Okay, by simply after some time we are applying this extraction, ethoxylate extraction method for 30 to 40 minutes or in several days also, several hours or several days also. Later the tenure period, just collect the solvent, just to distill the solvent, you will collect the crude product. From the crude product, first you need to identify the number of natural products present in it by using the column chromatography, by using the TLC experiments. Based on that, we can identify the how many number of components present in the crude product. Later, we are applying the separation methods. Okay, this is the isolation method. Okay, in your syllabus, one general isolation procedure is given. That is, I'm going to explain here. Here, he taken some citrus fruit material. Citrus fruit that is rendered, or leaves, or bark, or grass, anything. Leaves, lemongrass, or eucalyptus leaves. Eucalyptus leaves, jasmine oil, jasmine flowers. Jasmine flowers are having terpenes, right? These are the raw material. Any one raw material you take it. Okay, this is the part you treat it as. From this is groundwater flask. I am passing the steam. Just insert steam. Now steam will be exits, come out. Then it leads to the made into small pieces. Yeah. This raw material, first you take the sources and cut down into small pieces. All these are cut down into small pieces. Then apply steam distillation. Applying steam, then we'll collect the steam, pass the steam. Steam volatile, steam monoterpenoids. Came out along with the distillate. Right? Just separation method. Just by using a simple separation method. Separation or solvent extraction. Solvent extraction. We can separate the terpene. The simple distillation method. By simple this flowchart, we cannot able to understand. Whenever going to practical, we can understand very much. Okay, this is the simple distillation method. Now coming to next structure elucidation of or structure determination of terpenol. Actually, I have given the structure of terpenol in the previous. What is the structure of terpenol? This is the structure of terpenol. Yeah, we already know that is the reason we did draw it. But whenever we are isolated from the natural product, then we don't know the structure. When in such cases, how to identify or how to determine its structure? There is no spectroscoping method, right? There must be the compound in the purest form. They need to apply the several chemical reactions and a degradation experiment. Based on that, they are proposing the structure of the compound. Later, they are synthesizing the compound and comparing it with the already isolated one. Already 115 is now. 15 physical chemists are waiting for the class. Now I'm concluding this session. Don't worry about the syllabus. I will complete the syllabus. Uh, Even I can take the extra classes also. Don't worry. Okay. Now, if you have any doubts, one or two doubts I can take, then, or otherwise I will leave the class to the physical chemist. Yes, can I leave?
Thank you, sir.
Okay.